Now we move on to the problems that comes in connection with the properties of definite integrals. Now first I am going to discuss on the integration of modulus function. So I have the first integral as minus 5 to 5. Integral minus 5 to 5 mod of x plus 2 into dx. Now considering the function modulus of x plus 2, I have the value as minus of x plus 2 and plus x plus 2, isn't it? Now you write this for values that lies between minus 5 and 5. Now if you look at, when do we have the value for this mode function as minus of x plus 2? That is when I substitute for x plus 2 is equal to 0. I have the value of x is equal to minus 2 as the turning point. Okay, so I write this less than or equal to negative 2 or less than negative 2, and this positive values are for the values greater than 2. Am I clear? The modulus function here, I know that the modulus function is having two values. Negative values for some particular value of x and positive value for the function for a particular values of x. Now how to find the turning point of the graph? I equate the function x plus 2 is equal to 0. Now this is happening for a linear function. Okay, now I have written a cubic function this side. I will discuss it in later. So when you have the modulus function, and if it is a linear function, we equate the function to 0 and we get the value of x. By getting the value of x, that gives you the turning point in the graph of mode of x plus 2. So here when I equate to 0, I get the value of x is equal to minus 2. That means when I draw the graph, at the turning point of x is where x is equal to negative 2. Okay, this side I have minus of x plus 2, the other right hand side I have x plus 2. So this function here, which I have to integrate, I will split this function, let this function be I is equal to, that integrand is given to be I is equal to. So I will write it as minus 5 to negative 2. Okay, from minus 5 to negative 2, because it is restricted here from minus 5 to 5. So in this part, I take from minus 5 to negative 2, the value of the function is negative into dx plus, now from negative 2 to 5, the value of the function is positive. Am I clear? Okay, so minus 2 lies between the integral, minus 2 lies between the interval minus 5 to 5. This is exactly the property which we are using integral a to b f of x dx. I will write it as integral a to c f of x dx plus integral c to b f of x dx, where c is a value that is lying inside the interval or between a and b. Now here minus 2 is a value that is lying between minus 5 and 5. So I can split the integral into 2 in this manner. So now I can write this as minus of x square by 2 plus 2x within the limit minus 5 to negative 2 plus x square by 2 plus 2x within the limit minus 2 to 5. Now this is equal to negative of, when I substitute the upper limit, I get this as 4 by 2 minus 4, this is upper limit, minus lower limit is 25 by 2 minus 10. Okay, plus upper limit 25 by 2 plus 5 into 2, 10, upper limit minus lower limit is 4 by 2 minus 4. Okay, that is minus 2 comes here, it is minus of 4, so minus 4. So this is equal to negative of 2 goes here twice. So 2 minus 4, that is minus 2 minus, if I want I may write this as minus of 25 by 2 plus 10. Okay, plus 25 by 2. So much is of negative sign, plus 25 by 2 plus 10 minus This goes here twice. So 2 minus 4 is minus 2, minus of minus plus 2. Okay. Now I take this negative inside, that gives me 2 plus 25 by 2 minus 10 plus 25 by 2 plus 10 plus 2. Minus 10 plus 10 cancels. 25 by 2 plus 25 by 2, that is 2 times 25 by 2, 2 and 2 cancels to give me 25 plus 2 is 4, and finally I'll get it as 29. I hope this is clear. This is mere simplification this side. Now, in the next question I have integral of minus 1 to 2 mod of x cube minus x into dx. Now here, what I do is, I split the interval minus 1 to 0, 0 to 1 and 1 to 2. So, I split the interval in this form. Okay, why am I doing this? Because this is not a linear equation or a linear expression inside the modulus value. So, it is x cube minus x form. Now, what is the value of this function for the values that is lying inside this interval? See, if I take a negative 1 by 2, okay, negative 1 by 2 the cube minus or minus plus 1 by 2, that is negative 1 by 8 plus 1 by 2. This value is greater than 0, isn't it or not? So, I can say that in this interval the value of this modulus is positive. Now coming to the next integral. So, this is for this one. Now coming to the next integral, I take the value as half. 1 by 2 lies inside this. So 1 by 2 the cube minus 1 by 2. What do I get? 1 by 8 minus 1 by 4. Okay, this value is less than or equal to 0. So I can say that this particular expression will be negative x cube minus 1. Am I clear? Then coming to this, that means here it is positive. This expression is positive in this interval. This expression, which expression? This expression is negative in this interval. Now take a value here, 1.5, 3 by 2. Now 3 by 2 the cube minus 3 by 2. 3 by 2 the cube. That is, this value will also be greater than or equal to 0. Isn't it or not? That means here in this expression will be x cube minus x. That is, this expression will be positive. So how can I write this integrand to be? This I is equal to, in the interval minus 1 to 0, that is the first case, x cube minus x is positive into dx. In the next case, that is from 0 to 1, it is negative. So, x cube minus x is negative. Then, the other one is positive. 1 to 2, x cube minus x into dx is positive. Am I clear so far? Now I can integrate. So, when I integrate, what do I get? X raised to 4 by 4 minus x square by 2 within the integral minus 1 to 0 minus x raised to 4 by 4 minus x square by 2 within the integral 0 to 1 plus x raised to 4 by 4 minus x square by 2 within the integral 1 to 2. Now applying the upper limit and lower limit. When I apply the upper limit, it is 0 minus the lower limit. 1 by 4, here when I substitute minus 1 by 1 square, it is again positive. So this is minus 1 by 2. So one part is over, minus 1 by 4 minus 1 by 2. Upper limit minus lower limit is 0 plus upper limit 2 raised to the power of 4. That gives me 64. Right? 2 into 2, 4 into 2, 8 into 2, 16 into 2, 32. 32 by 4 minus 2 square, 4 by 2. This is upper limit minus Coming to lower limit, that gives me 1 by 4 minus 1 by 2. Sorry, this is 16 itself, correct. This is 16. Okay. 2 raised to the power of 4. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. I took x raised to the power of 5. Okay. So this is how I get. So this is equal to minus of, what do I get here? 1 by 4 minus 1 by 2. Isn't it minus 1 by 4? Okay. Minus. Again 1 by 4 minus 1 by 2, that is minus 1 by 4. Fine. Plus 6 goes here 4 times. 4 goes here 2 times. That is 4 minus 2 minus. Again 1 by 4 minus 1 by 2. That is minus of 1 by 4. So plus 1 by 4. This gives me, this is 1 by 4. This is 1 by 4. This is 2 here plus 1 by 4. That is 3 by 4 plus 2, which is 11 by 4. Cross multiply. 8 plus 3, 11 by 4. So this is how I do the integral of the modulus function when it is of the form x cube minus x into dx. Okay? Go through. Now we are going to do the next problem, that is integral 0 to pi by 4 log of 1 plus tan x into dx. Now this is a very important board question actually. So now here I apply the property that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay, so here if this is I, again I can write I is equal to integral 0 to pi by 4 log of 1 plus tan of pi by 4 minus x into dx. Okay, so that is in the place of a I have pi by 4. So pi by 4 minus x into dx. So this is equal to integral 0 to pi by 4 of log of 1 plus, now tan of x minus y, that is tan x minus tan y by 1 plus tan x tan y, isn't it? So I have the expression in this form. Now this is equal to integral 0 to pi by 4 of log of, cross multiply. Before cross multiplying, I'll write this as 1 minus tan x, because tan pi by 4 is what? 1 by 1 plus tan x, because again tan pi by 4 is 1. Now this is equal to integral 0 to pi by 4 of log of, cross multiply, 1 plus tan x plus 1 minus tan x by 1 plus tan x into what? Dx. Now minus tan x and plus tan x will get cancelled. Now what do I get? This is integral 0 to pi by 4 of log of 2 by 1 plus tan x into dx. Now I may write this as integral 0 to pi by 4. I am splitting it. Log 2 minus log of 1 plus tan x into what? Dx. Okay. Now I term this as equation number 2 and let this be equation number 1. Now 1 plus 2. 1 plus 2. So I plus I, that is 2i. 2i is equal to integral 0 to pi by 4 of log of 1 plus tan x into dx. Okay. This part plus this part. Plus integral 0 to pi by 4 of log 2 into dx minus integral 0 to pi by 4 into log of 1 plus tan x into what? Dx. Now this and this will get cancelled. What do I get? I is equal to 1 by 2. This 2 comes to the denominator. 1 by 2 into integral 0 to pi by 4 of log 2 into dx. Now if you look at log 2 is a constant. So log 2 by 2. Again you have integral of 0 to pi by 4 into dx. That is x. When I integrate it x, 0 to pi by 4. So log 2 by 2 into upper limit is what? Pi by 4. Lower limit is 0. So pi log 2 by 8. This is going to be the answer. Now let's see the next question. Integral 0 to pi by 2 root of sin x dx by root of sin x plus cos x. Now I apply the property here. Integral 0 to a f of x dx is same as integral 0 to a f of a minus x dx. So applying this property here, what do I get? I is equal to integral 0 to pi by 2 root of sine of, in the place of x I will have a minus x. Here it is pi by 2 minus x by root of sine of pi by 2 minus x plus root of cos pi by 2 minus x into dx. Now what is sine pi by 2 minus x? That is, we know it is cos x, isn't it? We have studied in our class 10. So root of sine pi by 2 minus x is cos x plus root of cos pi by 2 minus x is sin x into what? Dx. Okay. Now I have this as I and this as I. Now I take this equation as 1 and this equation as 2. 1 plus 2. What do I get? 2i. 2i is equal to integral 0 to pi by 2. Now if you look at both the equation has the denominators the same. So can I club the numerators? So I get this as root of sin x plus root of cos x denominator. Numerator is also what? Sin x plus root of cos x into what? Dx. Now numerator and denominator cancels and I get I is equal to 1 by 2 into integral 0 to pi by 2 of dx, which is 1 by 2 into derivative of, integral is x, 0 to pi by 2. Upper limit minus lower limit gives me what? Pi by 4. Okay? Am I clear? Yeah. So coming to the next one, that is integral 0 to pi of x dx by 1 plus sin x. As I have used the formula here, the same as what I am using it here. So I am not rewriting it. So I get I is equal to integral 0 to pi of x minus pi by 1 plus sine of x minus pi into what? Dx. Okay? Sine of x minus pi into dx. So, sorry, not x minus pi. It is pi minus x. Sorry, pi minus x. Pi minus x. So this is also pi minus x into dx. A minus x, isn't it? It is pi minus x into dx. Now, what is sine of pi minus x? As I know, sine of pi minus x is equal to sin x. So I can write this as 0 to pi of pi minus x by 1 plus sin x into dx. So let this be equation number 2 and let this be equation number 1. So 1 plus 2. I get it as 2i is equal to integral 0 to pi of x dx by 1 plus sin x. Okay. Plus integral 0 to pi of pi by 1 plus sin x. I am splitting it. Okay. Into dx minus integral 0 to pi of x by 1 plus sin x into dx. Now if you look at this and this get cancelled. And further, I get I is equal to, pi is a constant, so pi by 2 into integral 0 to pi of 1 by 1 plus sin x into dx. Now further, I cannot do anything over here. So what I do is, I multiply by the conjugate. So I get this as 0 to pi of 1 minus sin x by 1 plus sin x into 1 minus sin x into dx. So what do I get here? This is equal to pi by 2 into integral 0 to pi of 1 minus sin x by 1 minus sin squared x into dx. So this is equal to pi by 2 into integral 0 to pi of, I may write this as pi by 2 into integral 0 to pi of 1 minus sin x by cos squared x into dx, because 1 minus sin squared x is what? Cos squared x. That is 1 by cos squared x into dx minus pi by 2 is here, so it is a common thing, minus integral 0 to pi of sin x by cos square x into dx. Now What is this? This is pi by 2 into integral 0 to pi of sec squared x into dx minus integral 0 to pi of sec x tan x into ds. Now I integrate it. Pi by 2 is common to both these terms. So pi by 2 into, what is the integral of sec squared x? We know that it is tan x. So tan x within the limit 0 to pi. Minus, what is the integral of sec x tan x? That is sec x within the limit 0 to pi. Now this is equal to pi by 2 into, now tan pi minus tan 0, okay, minus sec pi minus sec 0. So this is equal to pi by 2 into, what is the value of tan pi? Tan pi is 0 minus tan 0 is minus 1. So this becomes plus 1 minus sec pi is what? 0. 0 minus sec 0 is 1. So I get the expression of this form, that is pi by 2 into 1 plus 1. That is 2 pi by 2, which is equal to pi. Okay.